Good day friends, how are you all? Hope you all are enjoying your life and your summer vacation very well. Now today we are going to discuss about the most important force of this universe. That is nothing but centripetal force. Now what is this centripetal force all about? Is it different that we have studied in force? No, it's not different. It's the same kind of force, but the point is it is generated by somebody or something. For example, before discussing it more, first of all, let's discuss about what is this force. Centripetal force is the force required to rotate one body around the other body. For example, now look at this body, right? Now this particular body, if you see, there is a particular center and it is performing a circular motion, right? So to understand it, let's draw a diagram. Now this is a circle and this is the center, right? So if you draw this and this is your point, this is your point P of mass M. This is the point mass and it is having a V, velocity, right? This angle will be 90 degree, correct? And this is the velocity vector which will make a 90 degree from the radius. And let's suppose this is the radius of the circle. So there will be a force acting towards the center which is known as centripetal force. So centripetal force Fc is equal to mv square by r, right? The m is the mass of the body and v is the velocity and r is the radius. Now as we know, since v is equal to r omega, and omega is, what is omega? Omega is angular velocity, right? So if you replace it here, so then we will get Fc is equal to m times r square omega square upon r, and hence we got m r omega square. So we have two formulas of centripetal force, that is Fc is equal to mv square by r, which is in terms of linear velocity, and Fc is equal to mr omega square, means when we know about the angular velocity, so we can use the angular velocity. Both are same, correct? Now you try to understand that why centripetal force is the most important force in this universe, because this is the required force to rotate one body around another, right? Like this. Means if something is rotating or if something is revolving around a particular point, so centripetal force is the main force required to rotate. Otherwise, what will happen? The body will not be able to revolve around it or rotate around this body. Now, look at the situation. There is the sun. You can consider the sun as the center, and entire planets, all planets of the solar system, they revolve around it depending upon their orbit, right? See this tremendous force of centripetal force which is being applied by sun on all planets of this universe. Do you think, was it possible to make all the planets revolve around something? So sun is having that force, and it is applying that force on every planet. Are you getting the point? Because this centripetal force is applied by sun on each planet depending upon its orbital velocity and the radius of its orbit. Did you understand this concept? This is the importance of centripetal force. So therefore centripetal force is the most important force in this universe. Right? Now in physical life and in philosophy also, we see that everybody is revolving around something. Right? Now let's suppose if Amitabh Bachchan comes here, right? So most of the people will try to revolve around him. Why? Because there is a hidden force applied by him on each and every person. No matter as it is in the brain. Right? But of course it is. Are you getting the point? So centripetal force is the most important force in this universe. Right? So we will take various examples. In your daily life, you must have seen everywhere the centripetal force are being applied. Whenever a body has to rotate around a body, right? Or whenever anybody revolves around any point or any different body, right? Is the point clear? Now, we have two expressions of centripetal force, that is Fc is equal to mv square by r and Fc is equal to mr omega square, where small r is the radius, m is of course the mass of the body, v is equal to linear velocity and omega is equal to angular velocity of the body. Right? Here one point is important to understand, that centripetal force is not a new force. Right? Then what will happen? So centripetal force must be provided by something, because of some property, because of some quality of bodies. Are you getting? Now you have to think about it. What is there which provides a centripetal force to various planets to revolve around the sun? That is nothing but the gravitational force given by Newton. Are you getting? So this is how we can calculate the orbital velocity of the planet or the satellite also. Now you think about satellite. What's the role of satellite? Satellite revolves around the planet. Right? So the orbital velocity of the satellite can be found just by equating this formula of centripetal force, equating it with the gravitational force applying by the planet on the satellite. Are you getting? So now this particular point must be clear, that a force is there, so it must be applied by somebody something and must be applied on somebody something. Who has applied the force, or which has applied the force, right, on which body? Now in case of centripetal force, when we talk about that earth is revolving around the sun, right? Earth is revolving around the sun. Centripetal force is applied by the sun and it's being applied on the earth. Is the point clear? So you need to understand this, and this is very simple, right? Now let's take some more examples. imagine a situation in which Earth revolves around the Sun. This is Sun, right? And this is Earth. E. Let's denote this with E. You join this line. Right? Now, why I am showing the direction towards Sun? Because it is the property of centripetal force that the centripetal force is applied by the body which is not revolving and is applied on the body which is revolving, right? So Earth is revolving around the Sun, right? In this particular concept, we consider that Sun is stationary and Earth is of course revolving. So this is stationary, means this is the center, and this is Earth. Earth is revolving, so it is applying force. Sun is applying force on Earth, right? Only then it is able to revolve Earth around itself. Yes or no? Correct? So this centripetal force is applied on Earth and applied by Sun. Try to understand. This is the most important concept, right? Now, let's suppose the mass of Sun is m and the mass of Earth is, let's take the mass of Sun as ms and mass of Earth as me, right? And let's consider this distance as r. Okay? So now you tell me that what's the value of centripetal force applied by Sun on the Earth? So centripetal force is mv square by r. So mv, then orbital velocity VO, v square upon r. This is the value of centripetal force applied on the Earth by the Sun, right? Now, as I have discussed, that centripetal force is not a new force, it is generated from something because of some property, right? Now here you need to understand that how can the Earth be provided the centripetal force. So that property is nothing but the gravitational force between Sun and Earth, right? Now what's the value of that force? The value of that force, that is Fg, is equal to G times ms, then me upon r square, that we have studied in gravitation, right? That if two bodies are there, so the gravitational force in between them will be equal to capital G into mass of one body into mass of another body upon the square of the distance between the two bodies, right? This point is clear? Correct? So now when you equate both the two expressions, so you will be able to find out that G ms me upon r square, right? It is equal to me v naught square upon r will be cancelled, right? Me and me will be cancelled. So what we will get? We will get VO is equal to square root of G ms upon r, right? Now the same kind of expression we will get while dealing with Earth and the satellite. Now satellite also revolves around the Earth, right? So what do you think? The same concept will not be applied? Of course it will be applied, right? So centripetal force is the most important force of this universe, right? As the name itself suggests, it is centripetal, the force applied towards the center on the body which is revolving around a particular center. Right? Here the center is the sun. Right? Here the center is this, and this is the body which is revolving. Right? Is the point clear? Now we will take more examples to understand it. Now this particular concept is important. Why? Because you must have studied in class 9th also, right? And the application part is in class 10th, and of course in 11th and 12th, right? So if your concepts are clear about centripetal force, so you study it for one time and it will be useful for more than 4 years, and of course throughout your life. I hope the point is clear. So let's take some more examples to understand it in a better way. Now, look at here. Let's suppose we have a hollow cylinder, right? And it is fixed with some system. The system is like that. At this particular hollow cylinder, this is a hollow cylinder. Now this particular cylinder can rotate with an angular velocity omega. What is this omega? This is the angular velocity with which this particular cylinder can be rotated, right? Like this, it can be rotated. Now, let's suppose if this radius has been given as a small r, and here there is a particular body, right? This is a body of mass small m, correct? Now, this surface of a hollow cylinder is having a friction. This surface is having friction, right? And mu is the coefficient of friction. Getting my point? This surface of cylinder is having friction, means this is not a frictionless surface, right? And the coefficient of friction has been given as mu, correct? This point is clear? This is this body. Now you need to find out the value of omega, the minimum value of omega, basically the angular velocity with which this rotor or this hollow cylinder which is rotated. So how much angular velocity has to be kept so that this body will not lose the contact, means it will remain in balanced condition. Now you try to understand, is it possible or not? Right? If you just leave it like this and the cylinder is not rotating, what will happen? This body will lose the contact and it will fall down, right? But here the body is not losing the contact because the cylinder is being rotated. So you need to find out that minimum value of angular velocity with which the cylinder must be rotated so that this body may not fall down, correct? And mustn't lose contact, right? Now, how is it possible? So, to understand it, first of all, we need to make the free body diagram of the body, right? Of this particular body. And how many forces are acting on this particular body, right? So, now apply your observation. As I have already discussed in my first lecture, that physics is all about your better observation, right? If you have a better observation, you can get the better result, right? Now see, how many forces are acting on this body? First is its weight of the body, that is mg, is in downward direction, correct? Now as the friction is there, so the tendency of friction is, its tendency is to oppose the movement of the body, right? Means, let's suppose if the body is here, so body will be having a tendency to move in downward direction, means it will try to fall. What will friction do? Friction will try to oppose it, right? It must be in upward direction or in downward direction. Now try to understand it. The tendency of this body is to fall, right? What friction will do? Because the job of friction is to oppose, right? So friction will be in upward direction, right? So friction will be in upward direction like this. This is the frictional force, Fs, right? Now, is there any other force? Yes, of course, because this body is in contact with the surface of the cylinder, so there will be a reaction force or the normal force from the surface, right? So it will be in this direction, correct? The reaction force R. Now, has it been completed? Yes, of course, it has been completed. This and this, right? Now if you see, for the body to maintain the contact, not to fall down, Fs must be equal to mg. Yes or no? Apply your brain. That if the body is not losing the contact, number one, if the body maintains its position in balanced condition while the rotor rotates, of course, this condition is must. If the rotor stops rotating, there is a chance that definitely the body will fall down. Is the point clear? So, for balanced condition, you can see that yes, Fs is equal to mg, means frictional force or force of friction must be equal to the weight of the body, correct? Now what's the maximum value of Fs is? That is mu m mu n, right? The maximum value of friction is mu times n, right? What is n here? N is nothing but normal, that is reaction, right? So this normal, or you say, is equal to reaction force of the surface is what? Is m r omega square, right? Which is nothing but the centripetal force, right? Because this body is revolving around this particular point, right? Being stationary within the frame of this rotor. Are you getting? Yes or no? Are you able to understand? If you see, the body doesn't lose the contact, means this body is revolving around it, around this particular point, right? You can make a circle like this. So this particular body must be having a centripetal force applied towards its center, right? Now, how this centripetal force will be provided? It is provided by the normal or the reaction of the surface. Look at here. Are you getting? Because as I have told you, the centripetal force is not the new force. It is generated by something, by some property or something must have happened that must cause a centripetal force to revolve one body around a particular center, right? So this particular body is revolving around it, so it must be getting a centripetal force. Here, how will it get the centripetal force? Through the reaction, right, of the surface of this hollow cylinder, right? It is having a surface. Now, at this particular point, now you see the reaction is there. Are you getting? So, due to this reaction, this particular body is getting the centripetal force, right? Which must be equal to mr omega square. Now, this normally nothing but n. What do you have to do? You have to equate it with mu times n. What's the value of n? Mr omega square, right? It must be equal to m times g. Correct? Is the point clear? So, what will you get? You will get m must be cancelled. So, you will be getting mu times r omega square is equal to g. So, what you got? You got omega is equal to g upon mu r and this. Correct? Mu has been given, r has been given, g. You know it, right? So, we can easily find out the angular velocity. Is the point clear? Now, this is how, if you are able to apply a simple concept of mechanics of centripetal force, so this is highly helpful for you to solve various problems, right? So, this application is in class 9th also, in class 10th also, and of course in class 11th, in class 12th, and in the competitive examination as well, right? Now let's deal with a different kind of problem, and the concept is same, the centripetal force, right? Now look at here, how the same concept of centripetal force is applied everywhere. If you understand it for the very first time and your concepts are clear, you can handle any kind of problem, because this concept is frequently used everywhere, right? Now let's suppose this is a magnetic field, right? This is a uniform magnetic field, and the magnetic field has been given as B. Magnetic field, it is denoted by B, capital B, right? And let's suppose we have a charge plus q of mass small m. It enters into this magnetic field with a velocity v, right? This magnetic field is also a vector quantity. Is the point clear? Means the situation has been given that there is a uniform magnetic field capital B, right? And its direction is inside the plane of this board, right? This symbol shows that magnetic field is, the direction of magnetic field is inside the plane of board, right? This is the direction of magnetic field. This is the charge plus q having mass small m, enters into this particular uniform magnetic field with a velocity v, right? This is what? Velocity. Now what will happen to this particular charge? To understand it, first of all, we need to understand that is there any force acting on this particular charge when it enters into this magnetic field? Yes, of course. And that force is known as magnetic force. Now let me give you the brief introduction of magnetic force. Magnetic force is defined as Lorentz force F, which is applied on any particular charge, which is equal to Q times V cross V. Right? Magnetic force F, which is applied on a charge in a magnetic field, is given as Q times its velocity, which is a vector quantity, and the cross product of velocity with the magnetic field, which is of course a vector quantity. Right? So this is basically the cross product of the velocity of the charge and the magnetic field in which it enters, and then multiplied with a scalar quantity, which is a charge. Right? It is defined as the magnetic force applied on any charge enters into a magnetic field. Is the point clear? So now we will just try to use this particular formula, but as I have told you that there is an application of centripetal force here, right? So something must be going on here. So let's understand it, that how it happens. Now look at here, when the charge enters here, when the charge enters into this magnetic field, what will happen? Let's suppose we are going to apply the right hand rule. Now in right hand rule, this particular finger will be denoting, or it will be directing the direction of the velocity, and this particular finger, this finger is denoting or representing the direction of the magnetic field, which is inside the plane of paper, right? So this thumb will be representing the force applied on the charge, and this force is nothing but the magnetic force applied on the charge, right? So here the magnetic force F, which was given by Lorentz, we call it Lorentz force. Lorentz force is Q times V cross V, and the direction of force F is the direction of V cross V, right? V cross V. If you apply the screw law, means you need to apply it like this. So the direction will be in upward direction. If you apply a screw, right, and you move like this, V cross V, because this is V, and this is inside the plane, this is your magnetic field. So if you take the cross product, you will get this direction, right, the upward one. So the magnetic force applied on this particular charge while entering into this magnetic field is in upward direction, right? Now when this happens, then let's suppose if the charge reaches here, it will experience its velocity is v here, right? And the force is applied in this direction Fm. This is magnetic force. So what will happen? This charge is bound to perform a uniform circular motion, right? Because this force is making a 90 degree from the velocity, right? So it will complete a circle. It will keep on revolving like this, right? So now the concept says when somebody is revolving around a particular point, means performing a uniform circular motion, right? So there must be a centripetal force, and a centripetal force is generated by something, right? Now here, how come the centripetal force is generated? It is generated by the magnetic force, right? So what will happen? You need to equate this magnetic force to centripetal force, right, that we have studied. So what is the centripetal force? Here, this particular, it will be mv square by r, right? R being the radius of this circle, radius of this circular path, followed by the charge while entering into this magnetic field, which is inside the plane of this board. Is the point clear? Right? So here comes Q times VB is equal to M V square by R. Now V will be cancelled by V, so you will be getting radius R is equal to mv upon qb, right? So this is the radius with which this particular charge will follow a circular path. This is the radius of that circular path followed by this particular charge when it enters into this magnetic field, right? So have you understood the concept of centripetal force? It's used everywhere, right? You need to understand it. Is the point clear? Now let's suppose if you have to find out the time period of this particular revolution, right? So how you can find out? We have a formula. Time period t is equal to distance upon the velocity. Yes or no? Time is equal to distance upon velocity. Now distance covered by this particular charge in completing one revolution is nothing but 2 pi r upon the velocity. Now here you see 2 pi r is nothing but this radius of the circular path, right? And v is the velocity. So you can find replace this value of r by v from here. So you will get 2 pi m upon qb. Now you see this time period is independent of the velocity of charge it enters, with which it enters into this particular magnetic field, right? So this time period is independent of the velocity of this charge with which it enters, right? Hope you must have understood completely about the concepts of centripetal force, which is the most important force in this universe. You try it and you apply it everywhere. Most of the time you must have observed that the centripetal force is there, right? So it's okay for today. Till then, take care, bye bye, and keep on understanding the concepts and applying your brain. Thank you, and wait for the next video. Bye bye.